మొబైల్ లాగిన్ కావాలి సార్ వస్తే పడుతుంది ఇది సైన్
గుడ్ ఈవినింగ్ సార్, సీతారాం బాబు సార్. Is my voice is audible, sir?
ఎక్కడ పడుకుంటావు?
చెప్పండి, అందరికీ ఏం చెప్పండి, మీరే చెప్పండి. నాకు చెప్పండి, మాట్లాడండి. ఫోన్ చేయమంటారు, నేనే మాట్లాడతాను.
సార్ గుడ్ ఈవినింగ్ సార్ సీతారాం బాబు గారు. గుడ్ ఈవినింగ్ మనోహర్.
Good evening, sir. How are you?
ఫైన్, హౌ ఆర్ యూ?
Fine, sir. After a long time.
గుడ్ ఈవినింగ్. గుడ్ ఈవినింగ్ సార్ బ్రహ్మారెడ్డి సార్ అండ్ జానకిరామ్ గారు సార్. గుడ్ ఈవినింగ్.
సార్ గుడ్ ఈవినింగ్ సార్. వెంకట సుబ్బయ్య గారు గుడ్ ఈవినింగ్.
గుడ్ ఈవినింగ్ సార్.
మనోహర్ గారు గుడ్ ఈవినింగ్ సార్.
Good evening, sir. Sitaram Babu, sir.
రెడ్డి గారు గుడ్ ఈవినింగ్. అన్మ్యూట్ సార్. బ్రహ్మారెడ్డి గారు అన్మ్యూట్ చేయండి.
సార్ గుడ్ ఈవినింగ్ సార్. గుడ్ ఈవినింగ్ ఎవ్రీబడి.
జానకిరామ్ గారు గుడ్ ఈవినింగ్ సార్. గుడ్ ఈవినింగ్.
గుడ్ ఈవినింగ్ సార్.
గుడ్ ఈవినింగ్ సార్ జానకిరామ్ సార్.
గుడ్ ఈవినింగ్ సార్.
నమస్తే వెంకట సుబ్బయ్య గారు.
నమస్కారం సార్. బ్రహ్మారెడ్డి సార్.
సీతారాం బాబు గారు.
జానకిరామ్ గారు
సార్ గుడ్ ఈవినింగ్ సార్. బ్రహ్మారెడ్డి సార్.
సార్ నమస్తే సార్, చాలా రోజులు బాగున్నారా?
Yes, sir, yes, sir.
బిలేటెడ్ సంక్రాంతి.
సార్ జానకిరామ్ గారు శ్రీకాంత్ గారు అని వస్తున్నారు సార్. లైన్ లోకి వస్తారా శ్రీకాంత్ గారు?
ఆయన కనుక్కుంటాను. ఇందాకనే మాట్లాడిన తోటి మళ్ళీ
రమ
మాట్లాడతాను.
గారు వచ్చారు. రమ గారు వచ్చారు. మేడం
సార్ స్టార్ట్ చేద్దామా సార్? సీతారాం బాబు సార్.
చేద్దాం సార్. చేద్దాం సార్. సార్ వెయిట్ చేద్దాం. ఒక 5 minutes వెయిట్ చేద్దామా?
23 మెంబర్స్
23
వచ్చారు.
ఉన్నారు. సార్ ఒక 5 minutes వెయిట్ చేద్దామా? స్టార్ట్ చేసేద్దామంటారా?
23 మెంబర్స్ వచ్చారు సార్.
ఓకే.
We'll wait for 5 minutes, sir. Right.
25.
నేను బయటికి నేను క్లోజ్ చేస్తాను, మొబైల్ క్లోజ్ చేస్తాను.
గుడ్ ఈవినింగ్ సార్. సార్ సీతారాం బాబు సార్.
స్టార్ట్ చేయమంటారా?
అందరు వచ్చారు కదా. స్పీకర్ ఉన్నారు,
ఓకే.
కన్వీనర్ ఉన్నారు.
Students are joining, sir.
ఓకే.
సార్
But just 2 minutes. Our students are
మనోహర్ గారు
joining.
ఎవరు? ఎవరు?
Students of ME and
Students,
BE.
ఓకే ఓకే
We have to give a reminder.
ఓకే ఓకే.
Just 1 minute, sir. Okay, can start, sir. The people will join.
Okay, sir. Sir, good evening, one and all, sir.
Good evening, sir.
Sir, good evening to the Chairman, Institution of Engineers, Dr. G. Venkat Subbaya Garu, immediate past Chairman, Dr. Brahma Reddy Garu, and the speaker for today, Ganapa Mohan Garu, Manohar Garu. This is a professor and head for Civil Engineering Department of Mathushri Engineering College. We also invite the chief guest for today event, Dr. Engineer G.S. Janikaram Garu. He is the General Manager for SCCL. Today actually we are doing a program in consortium with the Institution of Engineers, Hyderabad, the Telangana State Center, in consortium with the local center, Kottagudem local center, the 24th Endowment Lecture of Engineer L. Venkatakrishna Iyer Garu, KV Srinivasarao Garu, and Engineer ML Swami Garu. I also invite the speaker, the convener of the event, Rama Garu, to the event, and all the participants. I request the chairman G. Venkat Subbaya Garu to continue the event, sir, to preside over the event and continue the event. Thank you.
Thank you very much, sir. Dr. K. Sitaram Babu, FIE Honorary Secretary, IA Telangana State Center. So, respected today's chief guest, Engineer G.S. Jankiram, FIE General Manager, SCCL Kottagudem, and immediate past chairman, Kottagudem Local Center. Keynote speaker, Dr. Civil Engineering Department, Mathushri Engineering College, and my close friend, and Dr. K. Ramohan, FIE Chairman, Kottagudem Local Center, Dr. K. Sitaram Babu, FIE Honorary Secretary, IA Telangana State Center, Engineer B. Srikanth, MIE Honorary Secretary, IA Kottagudem Local Center, Engineer D. Rama, MIE Joint Honorary Secretary, IA Telangana State Center, and convener of the event, Engineer B. Brahma Reddy, immediate past chairman, council members of IEI, past chairman, past honorary secretaries, committee members, and corporate members of IEI TSC, and family members of Engineer L. Venkatakrishna Iyer, Engineer KV Srinivasarao, and Engineer ML Swami, budding engineers, ladies and gentlemen, good evening to all. Today I feel it is a great privilege and honor to be amidst this august gathering and extend a warm and hearty welcome to the chief guest, keynote speaker, and all of you to this Engineer L. Venkatakrishna Iyer, Engineer KV Srinivasarao, and Engineer ML Swami 24th Endowment Lecture. In the year 2001, the then erstwhile Andhra Pradesh State Center Committee had unanimously resolved to organize an endowment lecture annually at State Center in honor of great engineers, statesmen, Padma Bhushan, Engineer L. Venkatakrishna Iyer, former Chief Engineer in the Composite Madras State and past Chairman, IEI AP State Center, Engineer KV Srinivasarao, former Chief Engineer, Irrigation and past Chairman, IEI AP State Center, and Engineer ML Swami, former Engineer in Chief, Irrigation and CAT Department, who have rendered immense services to the erstwhile state of Andhra Pradesh in the irrigation and power sectors. Accordingly, the State Center of IEI is organizing the above endowment lecture this year also. And I am glad to inform that the Telangana State Center of the Institution of Engineers India has been regularly organizing 21 endowment lectures every year on the birthdays in honor of eminent engineers. The endowment lectures are being delivered by people of high eminence with considerable professional experiences to throw lights on important engineering topics of today's relevance. I take this opportunity to say a few words about great engineers, late Engineer L. Venkatakrishna Iyer, Engineer KV Srinivasarao, and Engineer ML Swami. Engineer L. Venkatakrishna Iyer served as Chief Engineer in the Composite Madras State and retired on May 7, 1943. He was associated with the Nagarjuna Sagar project, originally taken up as joint venture of Andhra and Hyderabad states. When the Andhra Pradesh came into existence in 1962, he was elevated as Secretary to Government PWD. At the ripe age of 88 years, he is a past chairman of the Institution of Engineers, Andhra Pradesh State Center. He was the recipient of Padma Bhushan Award for his meritorious work. And coming to engineer KV Srinivasarao garu, he joined the PWD as assistant engineer in the year 1939. He worked in various positions as assistant engineer, executive engineer, and superintending engineer in irrigation department. He became a chief engineer in 1962. Later, he was promoted as member Central Water and Power Commission, Government of India. He was appointed as chairman APSCB in 1972 and retired in 1974 with an outstanding record of service. He was past chairman of IEI AP State Center. He undertook many major irrigation projects and responsible for many power projects of AP. Engineer ML Swami served in the erstwhile state of AP in various capacities in Krishna and Godavari deltas, Vamsadhara project, Srisalem project, Nagarjuna Sagar project, and various other medium and minor irrigation projects. He also served as project engineer in the erstwhile AP State Construction Corporation and general management of National Hydroelectric Power Corporation, New Delhi. He retired as engineer-in-chief, Government of AP in the year 1983. Today, we have arranged Engineer L. Venkatakrishna Iyer, Engineer KV Srinivasarao, and Engineer ML Swami 24th Endowment Lecture on the theme Basic Concepts in the Design of Dams using Finite Element Analysis Against Calamity Loads. Since you are anxiously awaiting to hear the talk from our keynote speaker, I am limiting myself and hope that you will really enjoy this talk. On behalf of the Telangana State Center of IEI and on my own behalf, I once again extend a hearty welcome to the chief guest, Engineer GS Janakiram, FIE General Manager, SCCL Kottagudem, and keynote speaker, Dr. G. Manohar, MIE, Professor and Head, Civil Engineering Department, Mathus Engineering College, and all of you to this important event. Thank you, one and all. Now I request Engineer D. Rama, convener of the event, to introduce our keynote speaker. Madam? Madam Rama garu.
Sir, in the Kunnar, sir, she's కనపట్లేదు ఇప్పుడు.
సార్ నేను ట్రావెలింగ్ లో ఉన్నా. రత్నం సార్ మిమ్మల్ని చదవమన్నా.
నేను చదవమంటారు నన్ను.
సార్
Okay. Thank you very much, sir, Chairman sir, for having given me the opportunity to speak the profile of J.S. Janakiram garu, past chairman of Kottagudem Local Center and also the general manager for SCCL. After completing his intermediate, Janakiram garu passed section A in winter 1983.
I think keynote speaker. You have to introduce the chief guest will speak in the later, no?
Let it be, sir, no problem.
First you have to introduce keynote speaker. After keynote, chief guest will address.
Sir, keynote only. I told keynote speaker only, sir. Manohar
Okay, sir.
Okay, you can correct to start again with. No problem.
Okay. Manohar garu is BE in Civil, MTech in Structures and PhD from OU, and is now currently the professor and head of Civil Engineering Department at Mathusri Engineering College. He has basically 30 years of research and faculty experience, organized 10 national level workshops and 6 conferences in the department, more than 3 years teaching experience in University College of Engineering as guest faculty, BOS member in OU affiliated colleges at KG Reddy Engineering and Technology, Mallareddy Engineering College, Jawaharlal Nehru Technological University, member of Staff Selection Committee of Private Engineering Colleges in Hyderabad. His specialized areas are of research, basically in optimization techniques, physiologic applications, design of structures against calamity loads, design of structures for blast and fatigue loads, strength assessment of retrofitted structures. He has visited many engineering colleges as guest faculty at MBSR, MLRIT, Nalla Narasimha Reddy College, Mallareddy Institute of Technology, Vijaya Engineering College, CVR Engineering College. His experience is 1990 to 92 as junior engineer and executed residential and hospital buildings at Tirupati. 94 to 96 worked as assistant professors at MBSR College. 96 to 98 worked as assistant professor for civil engineering department in VR Siddhartha Engineering College, Kannur at Vijayawada. From 1998 to 2001, a senior assistant professor engineering subjects and established for CAD lab at Deccan College of Engineering and Technology. 2001 to 2011 served as associate professor and worked at different capacities in Vasavi College of Engineering, Hyderabad, and completed his PhD from OU in the year 2010. From 2011 to 13, served as professor and dean in Aurora Scientific Technological Research Academy, Bandlaguda. 2013 till date working as senior professor and head, Department of Civil Engineering, Matrushri Engineering College, and instrumental in securing the NBA, NAC, and autonomous status for the college. Actually, he has got a lot of seminars attended. I would not like to go into the details. And important, UGC FDP participated in 7 programs, and he published more than 40 technical papers in various national and international journals and conferences. Patents published in the field of civil engineering in 2, guided 5 PhDs, and 1 got awarded by Noida International University, and 4 scholars are working under his supervision from KLU and Annamal University. Guided 10 MTech projects from OU and JNTU Hyderabad. Guided more than 40 BTech projects. Education profile, already mentioned about the education profile. He is BTech from Tirupati, MTech from JNTU Hyderabad, stood university first in the year 1994, PhD in civil engineering from Usman University in the year 2010. Thank you very much, sir. I would now
Thank you for brief
hand it over back to the
detailed profile. Thank you, sir.
Thank you,
The
sir. I'll
best
hand it over
revenue
back to
of
the chairman, G. Venkata
engineering
Subbiah.
for this year.
So now I request keynote speaker, Professor
Shall I share
Manfred.
my PPT, sir?
Sir, please, sir.
So is my PPT is visible, sir?
Sir, yes, sir.
Yes,
It
sir,
is
it is.
visible.
Yes, sir. Yes, sir. Yes, sir.
PPT is okay.
So I am audible now, sir. So it's clear. So
Sir,
thank you,
clear,
sir.
clear.
Thank you for detailed profile of me, sir. Thank you, Sitaram, sir. And I thank all the people, not only for inviting me as a keynote speaker for the eminent people, eminent irrigation engineers of Andhra Pradesh. And I thank all the people. And my topic for webinar is basic concepts in design of dams using finite element analysis against calamity loads. Second. Myself, I am the working as professor in Mathur Engineering College. I must appreciate the people who are working for the technical field and conducting so many programs. I myself benefited from the Institution of Engineers. Actually, I joined in AIE as a member associate of Institution of Engineers in 1990 after immediately completing my BE, and I used our library also, and it was while preparing for the competitive exams. I was the first person getting beneficiary for preparing for the competitive exams. I thank all the people. Now my webinar consisting of the following contents. So the introduction, objective, then conventional method of dam design. Then importance of consideration of certain loads in design of dams and use of sensor technology and AI. Then design method of FEA. Then characteristics of calamity loads. Then outcome of design and discussion and overall view, then conclusion. So introduction part. So dams are the temples of modern India is statement made by the modern architect of modern India, Jawaharlal Nehru. So as a
Your slides are not moving, sir.
moving. Is it okay, sir?
You move it, sir. You move it.
Back. Second.
రత్నం గారు లేకపోతే హెల్ప్ చేయండి సార్.
Yeah,
Moving, sir. Now it's moving.
now it has moved.
Let's start.
No, no.
Is it visible, sir, now?
Yeah, introduction. Okay, you can start from here.
So it's okay. Now, former Prime Minister of India, then Jawaharlal Nehru said he is also architect of modern India. He said dams are temples of modern India. So we are getting bread and butter now because of the dams and irrigation projects also. So we have to take care of dams, and when you go for new constructions also, you have to see for the possibility of using the emerging technologies like artificial intelligence or sensor technology. So my seminar is going to on touching the various aspects of implementation of AIS and sensor technology for not only for the construction of the dams, but the safety and stability and structural behavior and maintenance of the dams in due course. I'm going to explain about various tools of the design of dams to be considered beyond the limits, such as calamity loads, like blast loads, then seismic loads, then we have landslides, then flooded water, then sometimes the uncertainty of the loads also, physiological applications. Then the use of finite element analysis is also emphasized. The method of entanglement analysis also briefly discussed. So this is the Three Gorges Dam of China. The profile, you can see the profile, the huge amount of water body. So there is a saying that if release the water at a time, it reduces the rotation of the earth by microseconds. Then you have the state Sri Salem Dam. See the profile of the Sri Salem Dam. So coming to the conventional method, before we were studying about the undergraduation level, dams are designed for not for all the elements of the dam or what we are going to choose in the finite element analysis. In the conventional method, we check randomly where we expect the maximum stresses in the dam, such as the uplifting pressures. We identify the what is the maximum tension is going to occur in the dam, and then we'll go for the factor of safeties for sliding of the dam and then overturning of the dam, and where you get the maximum bending moment and it causes the stresses. So these are considered to be designed for the dam. Now we require to study in detail about all the locations of the dam, because the loads are not general loads. If you want to go for the general loading, you can go for the ordinary conventional method. But if you want to go for the calamity loads that require the
Sir, can you go for presentation mode?
yeah,
కొంచెం సైజ్ పెరుగుతుంది.
is it okay, sir?
కాదు సార్, లెఫ్ట్ సైడ్ లేకుండా మీకు కిందికి రండి, ప్రెజెంటేషన్ మోడ్ వస్తుంది చూడండి. అంటే లెఫ్ట్ సైడ్ స్లైడ్ లేకుండా ఉంటే ఇంకా కొంచెం పెద్దగా వస్తుంది.
I am getting without that, sir.
సరే సార్, అయితే ఓకే ఓకే, కంటిన్యూ. ఎనీహౌ యువర్ స్లైడ్స్ ఆర్ వెరీ క్లియర్.
Clear, no? Okay.
ఓకే.
Yeah, finite element analysis is going to give the complete overall view of the stress condition of the entire dam, sir. So instead of getting maximum values, because the calamity loads are not within the elastic limit or within the limits. It goes beyond. Suppose if you take the landslides or the flooded water, it goes beyond the certain limits. We want to know where is the weak zone of the dam, and we have to identify it. According to that, we can go for the application of AI or sensor technology for identifying, and not only that, giving the alarms to the people. And basically the before finite element analysis in 1960s, there were different methods like Rayleigh-Ridge method and Galerkin methods. These are actually the scientists applied the mathematical formulation, just like assuming a functional, and what are the design parameters to get the maximum value of it. Just like mathematical functional, f of x is there, so you take the first derivative of it and make equal to 0, that become minimum value of that f of x for a particular value of x. The Rayleigh-Ridge method also like that. So they use the structural potential energy as a whole as a functional, and using a model, various constants of displacement models of the body, and you take the derivative with respect to the displacement model, making it equal to 0, that generates some equations for the values of design variables. So this was the method used by the primitive finite element analysis. Similarly, Galerkin method is also a method used for residual method. Is a method the minimizing the difference between the actual potential energy and the numerically made potential energy by the models, and it must be as minimum as possible. So with the elegant features of these two, and even the numerical methods like finite difference method, finite strip method, the finite element analysis is evaluated. So it made into number of domains, subdomains, and making the parameters and equations for each and every element, then assembling it and applying the applied loads and whatever the loads we are going to consider. So those loads are applied, and then the elements are disintegrated and got the what are the stresses at the element level. So that needs to get the what is the stress condition at various positions of the dam. So basically the finite element analysis changes or adopts the sorting of the problems. First we have different types of problems, and we need not go for all stress conditions, stress values like these direct stresses and shear stresses. So we can eliminate for certain problems like plane stress, plane strain, and axisymmetric problem. So as the dams are coming under plane strain problems, so plane strain problem is nothing but the dams are considered to be, if you take the z-axis, the length of the dam, the strains along the z directions are assumed as 0. Okay, then you have only direct stresses along x direction, y direction, and shear stresses in xy plane. So these are the stresses external caused by the external loads: sigma x, sigma y, sigma z, tau xy, tau yz, tau zx. So according to the direction xyz. Here we have to consider the as strains along the z direction. What are the strains in z directions? Those strains are made 0, and accordingly the stresses also will become 0. That means long direction of the dam, the strains will be there compared to the other dimension, it will be negligibly small. So we deal with only the strains caused by in the xy plane only. Those values are sigma x, sigma y, tau xy. So if you consider those three, the dam design is sufficient to go for the design. So general steps for finite element analysis, it deals with the minimum potential principle. As I told you, there is a formulation of stiffness matrix for each and every element. So first step is we have to divide the entire domain into subdomains. This is called a discretization. So this is the model we have shown here. The model here to the left side, we have the model with the number of elements, triangular elements, up to one level of the depth of the dam. And you can see, you can model it even beneath the depth of the dam, even using the rock area also. So using the rock mechanics principles, you can model it in the ground also. So this is the main advantage of the finite element formulation analysis compared to the conventional. So this is made into number of subparts, that is discretization is over. Then it deals with the number of matrices. So for each and every element, you have to develop the stiffness matrix. So it deals, this is the procedure for getting the stiffness matrix for a small element. So this small triangular element is there. This is one of the element of entire structure. So the element wise, you need to get the three matrices. One is B matrix, is the matrix with relation between strain and displacement, that you have to formulate first. Strain displacement matrix is a matrix. Then we have the constitutive matrix D is a relation between stress and strain. So if you have the integration of these matrices for you get the element stiffness matrix, okay, of the structure. And after combining all the element stiffness matrices, you get the overall or global stiffness matrix for entire structure up to the ground level also. Then we have to apply the boundary conditions. Boundary conditions are where it is supported, and we are going to get the modified stiffness matrix after applying the boundary conditions. Then we need to get this is the final equation K delta equal to F for entire structure. So we got developed for each and every element what is the stiffness matrix, and what is the load vector also. So the load vector is different types. There are self-weight and then surface traction forces. All these things are considered. Then we develop the stiffness matrix, a governing equation between the relation between stiffness matrix and the force vector. So after solving these equations, and we will get the delta vector, that is the displacement of each and every node. So we are going to get the displacement of overall stiffness matrix, that is stiffness of the displacements of various nodes of the structure globally, then they are transformed to the locally. So that means at each and every point of the structure, we are going to get the displacement. So that is the main concept of getting the stresses in the structure. The displacements are going to cause, if you restrict the displacements, you are going to get the stresses. That means it doesn't mean that you are allowing the displacement at various points of the dam. We are going to restrict that causes the stresses. That means where primary parameters are displacements in the structure. So we are getting those structures. If you are allowing, then we are restricting that. So by back substituting, you are going to get the stiffness, the stresses at various points of the various nodes of the elements. So this is the after finding out the stress components of a model structure. So it gives the two direct stresses as well as one transverse stresses, like tangential stresses, either compression or tension. So here basically this is a dam with the toe, you will have the compression tension, and whereas here heel you are going to get concentration of compression. So this is the way of finding out the stresses in the beam, in the dams. So we have
Manoj
to, sir,
సార్ అశ్విన్ మాట్లాడుతున్నా అది స్లైడ్స్ పోవడం లేదు సార్ దే ఆర్ నాట్ మూవింగ్
not moving.
దే ఆర్ నాట్ మూవింగ్ అండ్ యూ ప్రెస్ F5 సార్ F5 ప్రెస్ చేసి ఫుల్ స్క్రీన్ వస్తుంది స్లైడ్స్ ఆర్ నాట్ మూవింగ్ సార్
Right.
ఓకే సార్
It's okay. I think his screen is okay.
ఓకే calamity loads you press F5 sir so that it will be full screen visible.
The problem.
Full screen కనిపిస్తుంది F5
Press F5, it is not moving.
okay now it is visible sir now coming slides are moving now calamity loads it is showing now.
Yeah, calamity loads. So our aim is to not simply take the loads as general loads. So we have to go beyond that. Okay. So in order to apply the AI or using sensor technology, if the stresses are within limits like conventional method, you need not have any alerts. Okay. When the loads are moving beyond certain limits like blast loads or landslides, flood loads, seismic loads, then fatigue loads, sometimes temperature loads. So that causes the stresses are alarming. So by which you can get the signals that you can take the action. So basically there are different types of calamity loads. So basically the self-weight is a standard load we have to consider. So it depends upon the material you have used. Okay, the loads basically the load will be divided into how many joints, how many nodes we have, so many divided by W by divided by number of nodes. That gives the. Then we have surface loads. Surface loads, so you need to calculate what is the load in X direction, Y direction caused by the surface tractions. Surface traction forces are due to hydrostatic forces. So these forces can be components are taken by means of the direction cosines. Direction cosines are the cause values of the angle made with the x-axis, y-axis and z-axis by the surface traction forces. So this is the calculation I want to show you. The simple calculation, the length and the deviation from the x-axis, y-axis, z-axis. So deviation divided by length, that itself gives the cos theta. So these cosines, direction cosines are considered to be for the surface traction forces in x direction, y direction, and z direction. So this is the calculation I made. These are the forces we have for a constant force of 100 kN. So these are the forces, 1000 kN. These are the forces in the x direction, y direction, z direction. So in addition to self weight, you will have the superposition, the surface traction forces also. And these are to be superposed in the nodal directions, degree of freedom at nodal directions. So we have other type of calamity loads, so blast loads. So blast loads, characteristics are, depends on the height of the structure from the source of the blast. So there are different types of loads you have to consider here for the blast loads also, not only incident waves coming from the source of the blast, and not only that, the reflected waves coming from the ground also. So here they see two kinds of waves are coming from source of it, and so no doubt the incident waves will be stronger than the reflected waves. I need to consider the reflected waves also for the dam. So generally these loads are considered to be by means of max stem. Max stem is the projected effect of the blast pressures on a vertical plane that will be taken as the loads on the dam. Okay, so the intensity of these blast loads will be considered as TMT. TMT is the blasting material. So 1 TMT. So the intensity of 1 TMT, 2 TMT is 10 times greater than the 1 TMT. So it's the exponential scale, and so it will give the pressure on the vertical face of the dam that will be converted to the loads on the nodal points of the dam at each and every element. Then we have other types of loads as landslide loads, and especially for the embankment, the gravity dams are, so there we require to get the loads, and so the problem is the massive loads, mass of the entire earth is going to act suddenly on the dam, which causes the hazardous for the dam. So those loads must be considered. So generally the shear failure mechanism is considered to be the stability of the slopes, for the especially for the earth dams. We need to consider the slip circles, and we need to find out the shear failures and what is the shear stress and the non-direct stress and shear stresses. And according to this, loads must be given to this model of the dam. So these are the other types of number of landslides caused by hill areas. Then we have seismic loads. So this our country is divided into 5 zones and the intensity of earthquakes prone zones. Then we come under zone 2. Earlier it was zone 1. So, but we need to do this analysis of dams considering as maximum as possible, even 5th zone also. So we need to develop an artificial system, intelligent system, such a way that even if it occurs for the whatever the intensity of seismic loads we have for the 5th zone also, we must get immediate alarms and give the alert. And depending upon the zones we are going to take, and then as we are considering the foundation of the dam and the various elements in the foundation level also, and we can go for this analysis of response of the seismic loads effectively, as we are going to take the characteristics of the rock mechanics of the material available at the hard strata of the dam. So stresses can be analyzed by seismic coefficients and can get the warnings and alerts by depending upon the whatever the intensity of loads we are going to get, if it is beyond the limits. If the loads are beyond the limits only, we require alerts. So if the limits are, the loads in the or stresses in the material is less than, is not required. Then we have fatigue loads. For that, fatigue loads are the repeated loads. So the loads, the maximum loads are going to be repeated. That also causes hazardous for the dam material. So that we have to check how many cycles the loads are coming beyond the limits, and we have to get the alarm for that. Then we have uncertainty loads. Sometimes the dams will have the excess loads as design load compared to the design loads, and those are uncertainty loads. Means the design variables like loads or material or even water also, if the density is more and silting is more. So we need to work out the analysis if the loads are at least 10 to 5% more or less than the design loads. So we need to study, you have to make an attempt on what if studies also. It doesn't happen actually. So what if studies are required for applying the AI methods, AI systems. Okay. So we have to go for the sensitivity analysis, and according to the sensitivity analysis, so we can go for the alerts. Then we have temperature stresses. So temperature stresses are the variation of the temperature near the site also very important. It causes expansions that causes the displacements of the nodal points. In turn, it creates the more stresses. So temperature stresses also considered by using the finite element analysis. The temperatures are considered to be primary variables, and the heat energy as secondary variable. That means the functional is assumed as heat energy. According to that, we can find out what is the stress caused by the rise in temperatures. So that also causes. So all these loads must be considered for generating the analysis of entire dam. According to the analysis, we need to give the alerts. So this is the interpretation of the scope of application. So load sensors can be used for finding out maximum stresses. So while at the place of where you get the maximum stresses, you can identify with the combination of all types of calamity loads, and you can provide the sensors. High load sensors can be used, and you can get what is the maximum stress. According to that, we can give the alarms. And available location of stresses cause different types of loads, and its maximum values give rise to AI system for safety, stability, and structural behavior. And not only that, and the maintenance of dam in due course. And all these the what if studies are needed for generating the database for the AI system. And not only that, temperature stresses also can be used for this climate change conditions. Okay. So come to the conclusion. So the FEM model is very much needed for applying the AI or using the sensor technology for creating the warnings or alerts, and according to that, designs also must be made. And considering all loads that give comprehensive results. So taking into consideration each and every load, what is the response you can calculate. Similarly, all the loads combined together, what is the response? So that may help the generating the AI system for the safety, stability, and maintenance of the dam. And so maintain dam for sensor technology and warning, and sustainability for the climate change also ensured in the dam. So for the climatic changes like fire accidents and rising temperatures, Okay. Oh, thank you, sir. Hello.
Sir Venkat Subbai garu. Sir, any questions, sir? Meanwhile, any
Sir.
questions, please?
Sir, if no questions are there, okay, sir. Right. Thank you very much, sir Manohar Garu.
Oh, thank
So
you,
you have started your topic just as a basic one, but we have covered many advanced topics related to the dams, sir. So your lecture is very informative and interesting. Thank you very much for accepting our request and gracing the occasion as the keynote speaker. Thank you.
Thank you, sir.
Now I request Dr. K. Ramohan, FIE, Chairman, Kottagudem Local Center, to address on this occasion.
Sir, I'm not sure, sir. If he's there, fine. If he's not there, he's someone is
Not
actually.
joined, sir.
I don't know. He had joined earlier, sir. Looks like he's not not in right now.
Okay, sir. So now I request Engineer K. Engineer Banda Srikanth, MIE, Honorary Secretary, Kottagudem Local Center, to introduce our chief guest, Engineer GS Janakiram, FIE. Sir Srikanth Garu. Hello.
Like Srikanth Garu. Srikanth Garu.
He's also not there, sir.
Looks like, sir. Looks like.
I think presentation is delayed.
No problem, sir. They have to wait now. Sir, Sitaram Babu Garu, can you introduce?
Yes, sir. Yes, sir. Sir, thank you very much, sir, for again giving me the opportunity to speak. The profile of to read the profile of Janikram Garu is the past chairman of Kottagudem Local Center. I have already read a couple of his points. He is basically fellow in mechanical engineering division. Completed diploma in management from All India Management Association in '95. He has a certificate course in COBOL and other computer languages from SP University. PG diploma in metals management from Andamal University in 2007. MBA from SP University Tirupati in 2010. Joined SCCL as junior executive trainee on 2nd for June 1986 at Ellandu. Worked in open cast projects, auto workshop and stores in various capacities in different areas of SCCL. Worked as area engineer at Ellandu from 2018 to 2020. Worked as general manager, E&M, staff officer to director E&M from September 2020 to August 22. Presently working as general manager, E&M Solar Energy from August 2022 to till date, looking after the renewable energy department of SCCL. Where SCCL commissioned 245.5 megawatts of solar power plants and another 122 megawatts in different stages of commissioning, which includes floating solar energy, solar power plants and solar plants in 120 meters high dump yards, establishing battery energy storage plant, planning to convert decoated coal mine into a pumped storage project of 500 milliwatt capacity. And thank you very much, sir. Chairman, sir, G. Venkat Subbai Garu. I would request you to continue the event, sir, as the presiding officer.
Yes, thank you, sir. So now I request our chief guest engineer GS Janakiram Garu to address on this occasion. Sir. Sir Janakiram Garu.
Sir, is it audible, sir, now?
Yes, sir, you are audible, sir.
Go ahead, sir, please.
Once again, good evening to all the engineers who are participating in this event. So, Dr. G. Venkata Subbaya garu, FIE Chairman, Telangana State Center, and Dr. K. Sitaram Babu garu, FIE Honorary Secretary, Telangana State Center, Engineer Brahmareddy garu, Past Chairman, Telangana State Center of IEA, and Engineer Madam D. Rama garu, Joint Honorary Secretary, and who is the convener of this event, and Dr. G. Manohar garu, Professor, Civil Engineering Department, Mathurasri Engineering College, and keynote speaker of today's function. So, warm welcome, and I'm very thankful to the organizers for giving me this opportunity to be the chief guest of this present event, where the topic selected is very useful for all the practicing engineers and students. That is the basic concept in the design of dams using finite element analysis against calamity loads, and that is the endowment lecture of Engineer L. Venkata Krishna garu, Engineer KVS garu, and ML Swami garu, Engineer ML Swami garu. From the profile read out by Sitaram Babu garu, it is very much evident that these personalities have served the Ashwat AP state in different projects and different capacities for the development of the state and as well as the country. So, so the present topic is very much useful. That is the using the finite element analysis for the basic concepts and design of the dams using the with calamity loads. So Dr. Manohar Garu has explained all the topics in detail, how the design aspects are there in dams and all those things, and what are the calamity loads we have to consider, like seismic and sliding, and while doing the design of the dams. So, as already informed, it is very important topic where this finite element analysis is being used mainly for the engineers in different streams of engineering, particularly civil and mechanical engineering, where it is a numerical method of solving the complex engineering problems. It is used to predict how the objects behave under the various physical conditions, and where the FEA divides the large problems into a smaller, simpler parts, and commonly applied in structural, thermal, and fluid and electromagnetic analysis. So there are, so this I think this type of endowment lecture will help all the concerned persons who are involved in the design of any project, particularly structural engineers who are involved in the design aspect. So, from Kottagudem, as a past chairman of Kottagudem local center, so I am very much delightful, and now just now after seeing this endowment lecture, now we got the thought that similar endowment lectures may be possible to have at Kottagudem local center also, if our state Telangana state center permits us. So I am very much thankful for the organizers giving me the opportunity and be with you in this occasion. Thank you very much.
Thank you, sir, Jankiram Garu, so for your valuable message on this endowment lecture, and inspiring to start some more endowment lectures at Kottagudem local center. And we, as the members of IEA, we have to develop our centers, sir. So for the development of the Kottagudem local center from our state center side, always we will provide all the required support, sir. And at the same time, the support is required from you so that that center can also become one of the best local centers in India. Thank you. Thank you very much, sir. So now I request Dr. K. Sitaram Babu Garu to propose vote of thanks.
Sir, thank you very much, sir. for having excellent memorial lecture. The 24th Endowment Lecture, basically the Institution of Engineers, Telangana State Center and the Kottagudem local, local center combinedly have performed the on L. Venkatakrishna Iyer Gardi, then KV Engineer KV Srinivas Rao Gardi and ML Swami Garu. Memorial Lecture, Endowment Lecture. And we also should thank the Chairman G. Venkatsubbaiah Garu and also the Joint Honorary Secretary and the convener of the event, Rama Garu, for having made this event a grand success. We also should thank Sunil Manohar Garu, Professor and Head of College of Engineering, Mathrishri Engineering College, Department of Civil Engineering Head, for having given such a wonderful lecture, sir. I also thank immediate past chairman of Telangana State Center, Brahma Reddy Garu, for having been part of it. And also thank the chairman of Kottagudem Center, Ram Mohan Rao Garu. He is there for a short time, but he told me that he is busy with some other schedule, sir. But having come, we also thank him, sir, and also thank all the August gathering for having come to have such a, to hear to such a wonderful lecture. And we all thank one and all again. We now stand everyone for vote for national anthem, sir.
Secretary గారు
National anthem now.
సార్ సెక్రటరీ గారు ఈ సిస్టమ్ లో నేషనల్ యాంథమ్ లేదు సార్, సారీ.
Then, sir?
సిస్టమ్ లో నేషనల్ యాంథమ్ లేదు సార్, సిస్టమ్ లో.
Ratnam Garu.
ప్లీజ్ స్కిప్ చేయండి సార్, ప్లీజ్.
Okay. Okay,
Okay,
sir.
మనమే పాడదాం లేకుంటే.
We'll sing, sir, no problem.
Okay, sir, we will start.
Janagana Mana
మన అధినాయక జయ
జయ హే భారత
భారత
భాగ్య
భాగ్య విధాత
పంజాబ సింధు గుజరాట మరాఠా ద్రావిడ ఉత్కల వంగా వింధ్య హిమాచల యమునా గంగా ఉచ్చల జలధి గంగా తవ శుభ నామే జాగే तव शुभाशिष मागे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता
Jai
जय हे जय हे जय हे जय 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 हे
Jai Hind.
जय
Jai
हिंद
Hind.
Jai Hind.
Yes, once again, thank you for all of
Thank
you.
you, sir.
Thank you,
Venkata Subbaiah, sir.
Thank you, Janakram
Sitaram Rao,
Garu and
sir.
Sunil
Thank you.
Manohar. Thank you, sir.
Thank you.
Thank you, sir. Thank you, everybody.